Okay, this video is just going to work through questions 20 and 21 from the exercises for reviewing for the midterm. So, we have a random variable z with the expected value of 2 times z minus 3 equal to 11 and the variance of z minus 1 equal to 64. We want to find the expected value of z and the expected value of z squared. So these are questions that we're going to use a couple of things that we've learned. First of all, we've learned that the expected value, if we have a linear combination, a is a constant times a random variable x plus a constant b, that this is equal to a times the expected value of x plus b. We also learned that the variance of a times x plus b is equal to a squared times the variance of x. And finally, another thing that we're going to need to use in order to answer this question is the fact that the variance of x is equal to the expected value of x squared minus the mean squared. Okay, so those are the pieces that we're going to need. Now, first of all, I need to find the expected value of z for number 20. I know that the expected value of 2 times z minus 3 is equal to 11. This means that 2 times the expected value of z minus 3 is equal to 11, which means that the expected value of z must be equal to 7. Right, so there's our answer to question 20. Now for question 21, I don't know, I'm not told the variance of z, but I do know that the variance of z minus 1 is equal to the variance of z. And so I do know that the variance of z must be equal to 64. This is because when we sort of add a constant, it doesn't change the variability, right? So variability of z minus 1 is the same as the variability of z. Now I know the variance of z. I know the expected value of z. I'm trying to find the expected value of z squared. The variance of z equals the expected value of z squared minus the mean of z squared. The variance of z I know is 64. I'm trying to find the expected value of z squared. 7 times 7 is 49. What this means is the expected value of z squared has to be 64 plus 49, which is 113. And that's our solution. So again, it's important to remember that we can work with what we know about the expected value and variance of linear combinations of a random variable, and then we can also use our formula related to calculating the variance using the expected value of x squared and the mean. Thanks.